Okay, so now that I forgot which number we are, is it number 5, I think, of workshop 3. But now that we are done with descriptive statistics and correlations table, now we need to actually go to the regression model. So to do that, you go to analyze, and then you go to regression, and then to linear. And you will get this table. I already had something in there, so it should appear like this. So here you have to start with selecting your dependent variable. So the variable that you have here in your model, so happiness or SRI intentions or consumer behavior or global mindset, whatever you have as dependent variable. I will continue the example with happiness. So I guess happiness group 1 and 2 will have everything done by me. So happiness is here. The next step is again to include one by one the variables that you care. Pay attention in here. We are going to do 3 models. The first model is very simple, only happiness and your independent variable. I will assume the role of group 1 and 2, and I will say happiness and financial stress. This is the first model. We're going to do 3. So this is the first out of 3. Financial stress in here. Go to options. I think it's option. No, it's in statistics, and this will pop up, and click collinearity diagnostics. It's not normally ticked, so tick. Click on it, and then continue, and then OK. So we are going to do the analysis of the first model. Again, you have the lecture on quantitative analysis, so I will try to be quickly and to discuss what we need to check. The first thing that we need to check, basically 4 things. First thing that we need to check is the significance of the model, and that is shown in here. This number has to be lower than 0.15 at the very, very minimum. Some people even move it to 0.1 or 0.05, but let's assume 0.15 for this study. If this is below 0.15, we say that the model is significant, that if we do the model fit test, the model is significant, and we can actually build conclusions from this model. If this is more than 0.15, we cannot do anything with this model. We drop it and we move to the next model. We cannot interpret anything. We just drop it. Okay, so that's the first thing. Luckily, we can move on. We move to the next model. If you do your own test, like, I don't know, like SRI and bias, and this is more than 0.15, you drop it. You cannot conclude anything. Neither you support or you reject. You cannot claim anything. You just drop it. That's the next point. Because we survived, we can move forward. So we survived. We move to the next point. The next point that we need to check is the R-square. The R-square tells us how much of happiness is explained by this model. You need to check adjusted R-square, and it basically says that only 3% of the variance of happiness is explained by this model. That's quite low. In social sciences, we say that, again, I'm going into the lecture, but in social sciences, we usually are okay with 25%. It's still okay. And if we are very high, it's also a bit suspicious. It can be suspicious that one model can explain so much in social sciences. So I will say more than 0.2, it's okay. Less than 0.9, it's also okay. More than 0.9 is suspicious. Less than 0.2 is too low. So we are a bit too low. But let's move on. It's not as catastrophic. And we also understand, because we only have one variable, and you will see in the next models why it makes sense. The next point that we need to discuss is multicollinearity. Multicollinearity is tested in here in the BIF. This BIF should not be higher than 6. Some authors say 4, but 6 is still okay, it's still in the limit. So check if it's not more than 6, and hopefully no more than 4. In this case, we don't have any problem because multicollinearity tests that we are not measuring the same thing twice. We only have one independent variable, so we cannot have that problem because it's only one. But in the other models, I will explain in more detail. And so we survive also that. We more or less survive the R-square. Let's move on. I know it's not the best, but let's move on. We are okay with multicollinearity, no issue. So we have passed 3 tests. The final test, the significance of the variable. This has to be also less than 0.15, the same as here, less than 0.15. So here, the number is actually less than 0.15, it's 0.03. So we can claim that the variable has a significant relationship or a significant influence. Financial stress has a significant influence on happiness. The final point is to analyze this on this standardized coefficient, minus 0.2. The minus or the plus, whatever is in here, is very important because that shows that the relationship is negative or positive. In this case, the relationship is negative. That means that financial stress has a negative influence on happiness, and that is significant. We don't have multicollinearity problem. Our model is not that well at explaining the variance of happiness, so that's not the best. And we can actually conclude with 97% of confidence that the model works. So this is the first model, and that's how you conclude. You conclude that the effect is negative and it's significant and the model is significant. If your hypothesis was there is a negative relationship between financial stress and happiness, you support your hypothesis with model 1. That's the overall conclusion of model 1, the first support. Okay, so let's move to the next model. I think it will be easier now since we already have more, since we already know how it works. Also, when you open it, it saves what you previously did. It can be dangerous, but I guess that in this case, it works well. The next point, the second model, is to do the same, happiness with financial stress, but now we are going to add controls. And here it will make sense what we kept measuring for this, if in the end we cannot do anything with that. The reason is because you include them after financial stress, you include them, okay? And then you get this. Well, it's a disaster, this model. Let's go one by one. First, it seems that the model is the significance of the model, the F-test, the model fit, is more than 0.15. With that, we quickly finish. We quickly say this model doesn't work because this model has no significance fit. We said we cannot do anything. You cannot reject or support. We are done. The R-square is horrible, and well, we don't even need to look at that because it doesn't work. So model 2 doesn't work. The model has a significance higher than 0.15, so we cannot do anything with that. Let's go to the third model. Model number 3. So now let's remove these controls because we want to include this as controls: university satisfaction, locus of control, life balance. We want to include them as controls. For us, it doesn't matter if they are significant or not, but let's try with more controls if our model is better. So where is it? Here it is. So we start with university satisfaction. It's here. Then locus of control, life balance, and quality of relationships. And in the end, we also include the previous controls, the general controls, and it should look like this. Then you click OK. So now this model looks actually very good. We have a significance of minus point of less than 0.001, which is super good, that means this model is, the model fit is 99.99% of confidence that this model works. The adjusted R-square, this is what I wanted to show you. With only one variable, the model explained only 3% of the variance. When including more control variables into the model, now we explain more. We explain 32%. That's much better. So that is why it's so important to include more variables, to not rely only in this. And well, this didn't work, but it's very good that we have it like this. So first test, the model fit, we are doing great, excellent. Second test, the R-square is even better than before. We are very happy. Third test, the multicollinearity, nothing is more than 6. That's super good. We are great. But financial stress, that's the variable that matters to us. In this model, it is not significant. So a bit tricky. We were very happy with many things, but with the variable that we care about is not significant. So the overall conclusion of model 3 is that there you reject the hypothesis because you don't find significance, right? So model 3 doesn't support. So overall conclusion for group 1 and group 2, model 1 support the hypothesis. It's in here. It passed the tests and it's significant and it's negative, right? Negative. That one supports the hypothesis. The second one, we cannot do anything, doesn't work. And number 3, the relationship is not significant, although we passed all the tests, but it's not significant. So the overall conclusion is that you have mixed results. With one model, you have a significant negative effect supporting your hypothesis. With another one, the model doesn't even work. And model 3 doesn't have a statistical significance. So it's mixed results. You don't have, you do not support or reject the hypothesis. Different combinations that can happen. If all the models show the same results, like if all the models pass the test and if all the models have your variable that matters as significant, and they have the sign that you want, negative or positive, if everything works, the final conclusion is fully support. That is what you can call it. If all the, so that's one possibility, full support. If all the models work, and there is no multicollinearity, but there is no significance or the signs are the opposite to what you expected, then it's fully rejection. If all the models say this, everything is fine, you pass the test, but there is no significance in the variable or the signs are the opposite as you expected, fully rejection. What happens if you have 2 that support and 1 that reject? Is partial support, because you have more than support than less, right? The opposite. 1 supports, but 2 say no, partial rejection. And what we have in here, in this case, we have mixed results. We don't have, it's exactly the same. 1 says yes, the other says no. If you want to be more critical, you can say that this model is better because this model actually has more things to talk about. So these results are a little bit more reliable, but we assume that this model is also valid. We assume because it passed the test. This is not ideal, but it's still okay. So just because of pedagogical reasons, we can claim that this in case of group 1 and group 2, the general or final conclusion is that you have mixed findings. In one model, you support the relationship that you expected. On the other model, you find that there is no significance. So please do this for 3 models for each of your cases. So I'm going to grab a random one. So global mindset with materialism. So do the first mindset and math, only these 2. Next one, do mindset and math with the 6 controls, the general controls. Let's see what happens. Model number 3, mindset, math. these 4 as controls plus the 6 controls that we already have. That's your first model. So we're almost done. The last thing I want to show you is how do we translate these very ugly tables into the nice tables that we see in academic papers. That's the last thing. And actually those tables are what you have to submit in Canvas.